On this video, we're going to deal with some application problems that you guys had either in your worksheets or on in the book. So I'm starting at 3:37. I'm going to see how much I can do within, I think 15 minutes is my limit. So let's start off with, show that the graph of the function does not have a tangent line with a slope of 3. So I see the word tangent line. That tells me I got to find f of x, or f prime of x, sorry, a slope of 3, but it does not. So if it was 3, we would set it equal to 3. You want to show that that can't happen. So the first thing I would do is find f prime of x. Remember we said if you have no idea what to do, find a derivative to start. In first semester, that's usually your first step. Okay? And then I want to prove that a slope of 3 doesn't happen. So what I'm going to do is set this equal to 3 and try to solve. Problem is it's a fourth power. So I'm actually going to put this in the calculator and make that my y1 and make this my y2 and see if I can find an intersection. So here we have the calculator. I set up the first equation to be the first, the second equation to be 3, and I'm actually going to look to see if they intersect. So I'm going to press zoom and I'm going to do a standard window to start. This is a quartic graph, and you can actually see that the graph, which is up here, is not intersecting this line. And really, with more time, I would actually look to just make sure that this graph does not have any other kind of loops up and down. It's a quartic graph and it's positive, so it's definitely going to face up, but it could look like a W. And so I would zoom out a little more to double check. Now I'm going to actually do this problem also by hand. So here we go. Setting this equal to 3, I'm going to act as if this is a quadratic, so squared power, and I'm going to move everything to one side. And I'm going to have plus 2 equals 0. So really what I'm going to do is I'm going to rewrite this problem, and I'm going to do this instead. And I'll tell you why in a second after I get it written. What I just did was I'm doing a weird substitution. I'm going to actually say that a is the same as x squared. So that a is the same as x squared here, therefore a squared would be x to the 4th. And I'm going to solve this guy first. So if I were asking you to solve this, we would check to see, are there two numbers that are going to multiply? Let's see. I am not even going to waste my time with factoring. I'm going to use the quadratic formula to solve. So negative b plus or minus the square root of b squared minus 4, a is 5, c is 2, all over 2a, which is 5. And let's see. Negative 9 plus or minus the square root of, that is 81 minus 40 over 10. So I'm going to get that this is negative 9 plus or minus the square root of, hopefully 41. 41 over 10. And I'm going to use my calculator in a second because a was the same as x squared. So really what you're looking at, you're looking at that x squared is equal to negative 9 plus the square root of 41 over 10. And you're also looking to see that x squared equals negative 9 minus the root of 41 over 10. Okay, so what I'm going to do is actually steal this piece right here to the next page so I have a little bit more room. And we're going to use our calculator to help us out because I need to see about what number this value makes. So bring this up. All right, so negative 9 plus the root of 41, enter, divided by 10. And we actually get negative negative 0.25. And then the other one, I'm going to do negative 9 minus the square root of 41 divided by, 10. And we get negative 1.5. So if you look at both of these values here, that one And this one, you're trying to do an x squared equals a negative value, and x squared equals a negative value. X squared cannot equal negative 0.25. X squared cannot equal negative 1.5. Therefore, the equation has no solution. Therefore, going back, therefore, this here cannot be solved. So if you can't solve it, that means that there's no way for the tangent line to have a slope of 3. Next problem. So second one, find the equation of the tangent lines to the graph that are parallel to the line 2y plus x equals 6. So let's go through a few things. Tangent lines. So I'm going to need f prime of x. I see the word parallel that says same slope. And given this line, I know that I'm going to need that to look like y by itself. So I'm going to get y by itself. I get negative 1/2 x plus 3. The slope is negative 1/2. All right, so I need to find the equation of the tangent lines that are parallel to the line given. So parallel to the line, I have to have the same slope for the function and for the line. So the function's derivative is going to be a quotient rule. The top derivative is 1, the bottom derivative is 1. Low, d of high minus high, d of low, all over low, low. So I get x minus 1, negative x, negative 1, minus x minus 1 all over x minus 1 squared equals negative 2 over x minus 1 squared. So I need to set, let's use red. This is my derivative function, the slopes of the graph, and I want the slope of the graph to be parallel to the line who had a slope of negative 1/2. So let's cross multiply, and we get negative 4 is equal to negative x minus 1 squared. Let's just turn those positive, divide by negative 1. Therefore, if I want to solve for the x, I'm going to take the square root of this side, square root of this side, plus or minus. X minus 1 is equal to plus or minus 2. Therefore, x is equal to 1 plus or minus 2. Therefore, x is equal to 3 or x is equal to negative 1. The equations of the tangent line. So I found that x is equal to 3 and x is equal to negative 1. I found the points but not the equation of the tangent lines. So to get the y values, I'm going to substitute back into the very original to get the y value of the point. And why do we need that? There's two major things. I'm going to finish the problem over here in this corner. When I make a tangent line, I need two things. I need an entire point, x and y, and I need the slope. So what do we have? We have the slope. We know the slope has to be negative 1/2. We have the x part. We don't have the y part of the point. So that's what I'm doing in pink. I'm looking for the y value when x is 3. So the y value would be 3 plus 1 over 3 minus 1. So that would be 4 over 2, which is 2. And then in red over here to the right, y would equal negative 1 plus 1 over negative 1 minus 1. The top is 0, so this is 0. So in the middle, right here, so sorry that this is messy, my two equations would be y minus the y of the first point, 2, equals the slope times x minus the x of the point, which is 3. The second one would be y minus the y of the point equals negative 1/2 times x minus the x of the point, which would make that a plus 1. So there are my two equations of the tangent lines.